Welcome back to our new tutorial on internal energy. In this tutorial, we're going to look at how internal energy of an object relates to its temperature using the concept of specific heat capacity. When you switch a kettle on, the temperature of the water in the kettle increases until the water boils. The molecules or particles in the water gain energy and move faster as the temperature of the water increases. When the water boils, it means that the molecules have gained enough energy to move away from each other, so the water can turn into steam. The energy stored by the particles of a substance is called the substance internal energy. It is the sum of the potential energy and the kinetic energy. The potential energy of the particle here is related to their individual positions relative to each other. And as you know, the potential energy can be either gravitational or elastic, but they are both not really related to temperature, so we can ignore them. On the other hand, kinetic energy is the movement energy of the particles. It's related to their individual motions relative to each other, and this is the important one. Note that internal energy does not include gravitational potential energy, meaning the position of the substance with respect to the Earth, or the kinetic energy, which is caused by the motion of the whole system. Whenever you heat up a substance, it transfers its energy to its kinetic energy store of all the particles, so increases their internal energy. We measure it as an increase in temperature, because temperature is just a measure of the average internal energy of a substance. So, the more internal energy a substance has, the higher its temperature will be. However, some materials require a lot more energy to increase their temperature than others. For example, water requires 4,200 joules of energy to warm up 1 kilo by 1 degree Celsius, whereas 1 kilo of mercury can be heated by 1 degree Celsius with only 139 joules of energy. We call these numbers the specific heat capacity, which is the amount of energy needed to raise the temperature of 1 kilograms of a substance by 1 degrees. So each time 1 kilograms of water cools by 1 degrees, it will release 4,200 joules of energy to the surroundings.